Right, hi everybody, welcome back again. This is my third and possibly final video about how to use Excel in analysing your data for your IA. In this one I want to look at the subject of finding a correlation. In the previous videos, especially the one about the t-test, I looked at two data sets and tried to discuss how we might compare the two data sets and find out if there's statistical difference between one and the other. In this one, it's kind of the reverse. You've got a hypothesis or a prediction already that there exists a relationship between one data set and another data set, and in finding a correlation, you find out what that relationship is, what it is, and how strong the relationship is. It's worth just mentioning at this point that there are two possible correlations. You might have a correlation where you increase the numbers in one data set and you find that the numbers in the other data set increase. That would be called a positive correlation. Or you might find that you increase one set of numbers in a data set and in a response the numbers in the other data set decrease. That would be called a negative correlation. Okay, so let me show you some data that I was going to say I've collected. I've just made up this data. It's a paired data set. It means that we expect one data set to have an effect on the other data set. And we use correlations where we have a paired sets of data. Okay, so in this, I've made up these numbers, but I've said these are the results of ESS students, or a sample of ESS students, for what they got in paper one in terms of percentage and what they got in paper two in terms of a percentage score. This is student A, and this is student A's results. This is student B, and their results, student C, and so on. I've made a sample of 10 students. Obviously, in terms of the entire generation of students who sat the IB papers in that year, this is a small sample. It's not the entire population. That's important to bear in mind when we look at the relationship. Okay, so the first thing we can do is we can draw a correlation graph. So we select the data. We go to Insert, and here I know it's going to be a scatter graph, so I'm going to select XY scatter graph, and Excel pretty much does everything for me. Okay, that shows fairly well the relationship between, well, I should say, Excel will automatically put your first column on the x-axis. So this is paper one results, and it will put your second column on the y-axis. So this is paper two results. I can see there's a relationship where if a student scores fairly badly on paper one, they seem to score badly on paper two, and if they score well on paper one, they seem to score well on paper two. But that's not the end of the story. We can do a few things with this. Now, first of all, I don't particularly like some of the things that Excel has drawn this, how Excel has drawn this graph. So first of all, I'll get rid of that title. Secondly, I don't like how it's squashed all the data into the top corner because it's gone down to the origin of both axes, 0, 0. So I'm going to reduce the axes. Right, so to do that, I can click on the axis, or double click rather, and I get these options. This tab that's got a little graph on it gives me some things I can play around with the axes. First of all, I can reduce the size of the axes. I'm going to reduce from, I'm going to go from 0 to 50% on the y-axis, and then I can select the x-axis, and I think I'll do the same again. I will go to axis options and reduce the axis there as well. All right, I think that shows the relationship a bit more clearly. All right, secondly, and I've mentioned this before, I don't like the way that Excel doesn't automatically put a box on the axes so you can put the axes titles. So I'm going to go to chart elements, add chart element up here. You need to select the graph first, and I will put axis titles. There's a box for the x-axis, and there's a box for the, let me try that again. Axis titles, primary vertical, axis titles, primary horizontal. Okay, and I'll put my, as I said, I'll do the x-axis first. That's going to be my first column, which was paper 1 results. Important to put a unit if you have it, is in percent. And on the y-axis, it's going to be paper 2 results, also as a percentage. Okay, there's one or two more things I can do. First of all, it'd be very nice to show a trend line. So you can select your data and you can either right click or go to add chart elements, and you can tell it to add a trend line. In all of the cases, really, it's going for our use, it's going to be a linear relationship, so it'll show a linear trend line. Right, now, secondly, I don't like the way that Excel starts at your lowest value and finishes at your top value. I certainly think it's important to extend the trend line to the y-axis. To do that is a bit complicated, but you can go to forecast here, which allows you to extend the trend line. I'm going to extend it backwards so it crosses the y-axis, and I think if I extend backwards 10 points, it will allow me to do that. You can also extend it forward if you're thinking of doing any kind of regression analysis where you're looking at values that are off the top of your trend line. Okay, that's almost it. The other important thing I'm going to add here is if I click again on the line, on the trend line, it allows me to add here what it calls an R-squared value. So if you click on that box, it adds the R-squared value here. It's very small, so I'm going to put it in a bigger font so you can see it. It's like 15 size. It's given me an R-squared value of 0.7595. I don't like the term R-squared value, so I'm going to change that to correlation, I hope I spell it correctly, correlation coefficient. Hopefully I've spelled that correctly. All right, a correlation coefficient of 0 would tell you that there's zero relationship between the x and y axes, or there's zero relationship between, your first data set and your second data set. If your correlation coefficient is 1, then you have a perfect relationship between your data set 1 and your data set 2. In that case, all of the points would be on the line. Obviously, that's impossible in environmental sampling. All right, so in a lot of cases, in fact, most cases I've possibly seen in the past, students would stop there. Maybe in their discussion, they would explain that it's a good correlation coefficient or a bad correlation coefficient. But I do think it's important that you actually know something about what that coefficient actually means, other than 1 is perfect and 0 is non-existent. Now, to do that, I suggest you try this calculation. It's the calculation of standard error. Okay, and the calculation of the standard error of the correlation coefficient. This is the formula I'm going to use. The standard error is 1 minus the correlation coefficient, the whole thing squared, divided by the square root of the number of samples. Basically, it's taken into consideration how big your correlation coefficient is and how big your sample was of a larger population. Obviously, the larger the number of samples are, the more confidence you can have in your correlation coefficient. All right, so I'm going to do this calculation on Excel. I hope this makes sense. So let me do, first of all, the numerator on the top, and then in a separate box, I'll calculate the denominator. So the numerator is going to be equals, open brackets, 1 minus the correlation coefficient, which was 0.7595, close brackets, to the power of 2. That's the top part of the formula, fairly small number. And the bottom part is the square root of the number of samples. To do that on Excel, you write equals square root, and it's going to be the square root of, well, I know I have 10 students, square root of 10. Okay, So one standard error is basically going to be equal to this number divided by that number. So equals that number slash that number. That's my value of one standard error. Now you don't really have to understand what that means, but if a better actually number to calculate is 2 times the standard error, and I'll try and explain why in a minute. So that's going to be equal to 2 times that value, enter. That's 2 standard errors. Now 2 standard errors is an important number to know because we call 2 standard errors the 95% confidence limit, or sometimes we call it the 0.05 confidence interval. Let me explain why that's important. If I take, I'll try and draw this manually. If I take my correlation coefficient, hopefully my pen works, take my correlation coefficient, okay, thank you. Take my correlation coefficient. I got a value of 0.7595. If I subtract 2 standard errors, so I'll do it on my calculator, 0.7595 minus 0.3 minus 0.0366. That gives me a value of 0.7229. So it's so squashed. And if I add 2 standard errors, 0.7595 plus 0.0366, 2 standard errors on that side is going to be 0.7961. Now let me try and get this right. What that means is if I increase the sample size, I take another 20 students, and I take the correlation coefficient of that new sample, I can be 95% certain it will lie between that range, and it's a small range. If I increase again another 20 students, I can again be 95% certain that the correlation coefficient will lie between that range. Because the range is small, I can be certain in this case that this relationship, it's real, it does exist between paper 2 results and paper 1 results. If I did the same thing and I had a poor correlation and I had a small sample size, I would have an absolutely huge value for 2 times the standard error. It might be so big actually, it might actually go beyond the limits of the x-axis, and I might even go into negative values. If I've got a huge 2 times standard error, then I know that there's a good chance of that correlation doesn't really exist at all. So I think it's worth, as well as putting your correlation coefficient into your IA and discussing it, I also think it's worth calculating 2 standard errors, and that will give you a better handle on whether your correlation coefficient is a good correlation coefficient or a poor correlation coefficient. Alright, so I know I've gone on too long. I apologise for that. I hope this made sense, and I will speak to you again in our class where we'll continue talking about the IAs. Alright, take care everybody.